Good morning, students. So now in today's class we have to discuss with the data visualization. So before about discussing about the data similarity and dissimilarity, first how to visualize the data. So the data visualization we have to discuss. Mainly we have to concentrate on why data we have to visualize to gain the insight into an information space by mapping data onto graphical primitives. So here, what is the mean? Simply, the overall view of the data you have to represent it with a graphical way. That is, you have to represent it with the data visualization. It mainly the data visualization provides qualitative overview of large data sets. Qualitative overview of the large set. For example, you have to consider a huge database like our college database or university database. How many colleges are there in each college? What is this is the overview of the entire university database data set. Simply, that is the data visualization. Simply, it provides the qualitative overview of the large data sets. That is simply data visualization we have to use. And it is search for data visualization, search for the patterns, trends, structures, irregularities, and the relationship between the data. These all you have to find out with the data visualization. And also it helps the finding the interesting regions, suitable parameters. And also it provides the visual proof of the computer representation derived. So this is regarding to that data visualization. So mainly we have to gain the insight of the information, and it provides the qualitative overview of the data and searching for the data, and help to finding the interesting results. It's mainly you have to provide the qualitative visual proof you have to represent it with the data visualization. And here the categorization of visualization methods. So these all methods you have to discuss in that computer graphics CG subjects. So over there, what are the methods you have to use? That is a pixel oriented visualization technique and the geometric projection visualization techniques. That is icon based visualization techniques, hierarchical visualization techniques, and visualizing complex data and relations. These are the 5 types of visualization methods we have to use and the data visualization. Pixel-oriented geometric projection visualization techniques, and these are the techniques you have to use mainly. So here, the first one is the pixel-oriented visualization technique. For a data set of m-dimension data set, create the m windows on the screen, and for each dimension, m-dimension values of the record is mapped into the m pixels at the corresponding positions in the windows. That is, you have to represent a pixel-oriented visualization technique. The colors of the pixels reflect the corresponding values. Laying out the pixels in a circle segments. So already we have to discuss that what is the geometric projection and visualization techniques. So here geometric projection techniques, the geometric projection visualization techniques, the visualization of geometric transformations and projections of the data, discrete visualization, scatter plot matrices, landscapes, projection pursuit techniques. So these are all techniques we have to use. So this is regarding to that geometric projection technique. Similar way, direct visualization methods, scatter plot. So whatever you have to discuss with all, you have to represent it. So these are the regarding to that. These different visualization techniques we have to use in the visualization method. And the last one is that is simply call it as measuring the data similarity and dissimilarity. So now in the measuring the data similarity and dissimilarity, mainly you have to concentrate on what is the similarity, and dissimilarity. Similarity represents the numerical measure of the how alike the two data objects. Here you have to represent numerical measure how like the two data objects. The value is higher when objects is more alike. For example, similar data objects you have represented as the range of 0 to 1. So dissimilarity, here you have to represent the distance. The numerical measure of the how different two data objects are lower when objects are more and similar. The numerical measures. Generally, what are the attributes you have to use? That is the different types of attributes you have to use. In numerical attributes, mainly you have to represent it in dissimilarity. A numerical measure how different two data objects are lower when objects is more alike. Minimum dissimilarity is often 0, and whereas in similarity the range is 0 to 1, but whereas here in dissimilarity minimum dissimilarity is often 0. The upper limit varies. So here the data matrix how you can represent it here. The data matrix you have to represent x of 1 to x of np. That is the number of rows and number of columns. So n represents the number of rows and p represents the number of columns. That is the n data points with p dimensions. That is simply call it as n into p. that you have to represent the data matrix n into p matrix, that is the n data points p dimensions. So that you have to represent it as a x of 1 1 2 x of np. That is the last element in that matrix. So here we can represent the x11, x1f up to x1p, x of I1, if to ip. Similar way n1 to np. That is the data matrix. Next one is the dissimilarity of matrices and data but registers. Dissimilarity of the matrix and data points we have to represent it as the diagonal elements are 0 and the values you have to represent it as n data points, but the registers only the distance one. We have to represent the distance between the 2, 1 and 3, 1 and 3, 2 and n, 1 and n, 2. Like this way we have to represent. That is a dissimilarity matrix. Generally we have to represent it with the triangular matrix in single mode. But compared to the data matrix, it is represented as in 2 modes. But whereas in dissimilarity matrix, you have to represent the single mode. So rows and columns. Rows and columns you have to represent it as in a triangular matrix. From the distance matrix that you have to represent it as the diagonal elements are represented zeros and lower, whereas in triangle way, in triangle values are represented with the distances between the points. So what are the attributes we have to use? So generally, you have to measure the attributes, that is the nominal attributes, can take 2 or more states, red, yellow, blue, green, generalization of the binary attributes. Method 1, simple matching, hash of the matches, p equal to total of variables. So number of matches and p equal to total of variables. T of ij equal to p minus m by p. By using this formula, you can find out the proximity measure for the nominal attributes. That is the method 1, simple matching. Method 2, use a large number of binary attributes, creating new binary attribute for each of the m nominal states. In the first method, you have to represent the simple matching, and the second method, you have to represent the large number of binary attributes. See this proximity measure of binary nominal attributes. You have to represent it with this 2 methods: simple matching and a large number of binary attributes. And the next one is another type of attributes we have to use it in data represents the data. That is the binary attributes. The binary attributes you have to represent only 2 values, that is the 0 or 1. It is a contingency table of the binary data we have to represent. That is the object I to object Z. That is the 1 to 0 or 1 to 0 or 1 1 you have to represent it up to 0 0. So 1 1 you have to represent it as Q. 1 0 represents represented as R, and 0 1 you have to represent it as S. see here, this is the contingency table of here you have to represent so here you have to see that is the one you have to represent sum is q plus r. Similarly, that is the GST. So it's the sum is s plus t. Similarly, you have to represent that is the q plus s is the column by sum for the first column, and the second column sum you have to represent it as r plus t. Similarly, first row sum is q plus r, and second row column is s plus t. So finally, we have to represent it as p. Distance measure of the symmetric binary variables d of ij equal to r plus s q plus r plus s plus t. So by using this formula, you can find out the distance measure of the symmetric binary variables. So whenever you want to find out the asymmetric binary variables, d of ij equal to r plus s divided by q plus r plus s. So only the difference here for the symmetric binary variables and asymmetric binary variables, that is except t. In the division part, we have the except t, remaining is the same formula. So Jaccard coefficient of this we have to represent that is the measures to the symmetric binary. Sim Jaccard of ij is equal to q by, that is in the place of rs, you can use the q q by q plus r plus s, that is the 1 minus d of ij. So Jaccard coefficient of the same of the coherence, you can find out the value. Coherence equal to that is the coherence of ij equal to that is the so SUP of ij, SUP of I plus SUP of j minus SUP ij, that you have to represent it as, that is the sum of the matrices sub a particular row and column you have to represent it, that is the q by p plus r plus q plus s minus q. By using this formula, that is Jaccard coefficient. Next one is the numerical attributes. Here, before discussing about the numerical attributes, similar way you have to represent the dissimilarity between the binary variables. Proximity measure you have to come discussed. Now you have to discuss with that dissimilarity between the binary variables. That is the name, chart. That is the gender. You have to represent it: fever, cough, test 1 and test 2, test 3, test 4. So all you have to gender is the symmetric attribute. Okay, the remaining attributes are asymmetric binary. So gender could not be changed, but whereas asymmetric binary attributes are changed. So gender is first you have to represent the male, and after a long time also it represents as male only. But whereas fever and cough, the value, the testing weight, whenever you have to test, the fever positive have to converted into So now we have to represent the binary variables. Gender is the symmetric attribute, and here gender is a symmetric attribute. The remaining attributes are asymmetric binary. Let the values y and the p is 1 and the value n equal to 0. D of jock, you have to represent the 0, 1 and 2 plus 0 plus 1, you get the value that is the 0.33. There are jock and Jim, the values you have to represent it as 1 plus 1, all you have to represent 0.67. Whereas Jim and Mary have to represent it as 1 plus 2 and 1 plus 2, getting the value 0.75. Let the values y represents the y and p is the 1 and the value is n equal to 0. So next one is the numerical attributes. The data you have to represent z score value z equal to x minus mu by rho. That is x represents the raw score to be standardized. Mu represents the mean of the population and rho represents the standard deviation. By using the, you have to find out the standardizing the numeric data by using the formula z equal to numeric data the alternative way, calculate the mean absolute deviation, where m of m, that is the 1 by n of x of 1f plus x2 of f plus up to x of nf. So by using this formula, you can find out the mean absolute deviation that is the value. Standardized measure you have to find out, that is the z of if equal to x of if minus m of f by s of f. So by using this formula, you can find out the standardized measure for z score value you have to find out for the standardizing numeric data. So see here, that is the example you have to represent distance on numerical data. I have to, by using this formula, you can find out the distance of numerical data. That is the Minkowski distance, the popular distance measure you have to find out T of ij equal to h root of x of j minus x of j 1. So data matrix we have to represent it here. h root of x of with the mod of x of I1 minus x of J1 of mod of h, and x of mod of x I2 minus J2 mod of h, and up to x of mod x of IP minus x of JPH. So this is the Minkowski distance, the popular distance we have to measure on numerical data by using this formula only. So you know that generally the distance between the 2 points, generally you know that s into s minus 1 the and the root of s into s minus 1 and s minus 2 whole square. So by using that formula, similar way here also we can find out the distance between the n points, but over there you have to use the 2 points, but whereas here you can use the distance between the n points. That is the I value you have to represent it as x of I1 to IP, j values you have to represent of J1 to JP. Two p-dimensional data objects, h is the order you have to represent it, and h norm. Properties have to represent the symmetry and triangle inequality, positive definiteness of various properties we have to represent it, and generally the distance that satisfies these properties is a metric. So generally you have to find out the distance on numerical data by using this formula one. Special case of Minkowski distance, that is you have to represent it as Mahatin, for example h1 is equal to 1. Mahatin, that is the city block L1 norm distance you have to find out. The Hamming distance of the numbers, Hamming distance, by using the Hamming distance, the number of bits that are different between the two binary vectors. D of ij equal to mod of x of I1 minus x of J1 plus mod of x of I2 minus x of J2, and so on up of mod of x of IP minus x of JP. Similar way, H2 value we have to find out, that is the L2 now Euclidean distance you have to find out. X of Dij represents, and previously you have to how you can represent. Here you can use the 2 points only, but previously you can discuss with the n points. Root of x of I1 minus x of J1 whole square, that is a mod square, plus mod of x of I2 minus x of J2 square up to x of IP minus x of JP square. This is the Euclidean distance you have to find out, and the first one is the h value is the Manhattan distance. So the power is we have the only one, but whereas here the power is 2. If the h value is infinity, supermum, that is maximum value is infinity. This is the maximum difference between any components of the vectors. D of ij equal to limit h tends to infinity, sigma summation of f equal to 1 to p x of if minus x of jf of h whole power 1 by h. That is the max of jp fp, that is the x of ip minus x of jf. So this is the distances you have to find out. It's the diagrams ordinary variables. An ordinary variable can be discrete or continuous. You have to represent. Order is important, and it's based on rank. You have to represent it here.
Sir, your voice is not audible.
So data objects generally you have to divide into 4 types. That is the nominal attributes, binary attributes, ordinary, and numerical attributes. These the numerical attributes are divided into 2 types: interval scaled and ratio scaled attributes. Now, many types of data sets you have to use it in this. These are what are the attributes you have to discuss. All these attributes you have to use in these data sets. So that is text data sets, graph, videos, email, web data sets, image data sets. You can in all these data sets we have to use these attributes. So here main the gain inside the data from this data you have to gain the basic statistical data description, and that means you have to summarizing the data. Whatever the data you have, that all data you have to summarize by using the different methods and graphical displays. That is the overview of the data you have to represent it with this basic statistical data descriptions. And similar way, the data, whatever the data you have to analyze, the data you have to represent it in graphical form. That is, you have to using the data visualization. That is the mapping of data on graphical primitives. Similar way, some of the data is similar. That is the same data you have to copy it from one database to another data. So you have to eliminate that type of data. So these all things you can do before data pre-processing. For example, why you have to learn this concept? For example, you have to use the different databases. You have to represent it as you have to collect it in data warehouse. Okay, clear? So whenever you have the all data you have to collect it in a data warehouse. First, some of the databases have different data sets. So all data we have to collect it. Some data set have not filled with the all values. Okay, that means some of the fields are not filled with the actual values. Some of the fields are we have to represent it as numeric, but we have to fill with the characters. So this is the inconsistent data. First, this inconsistent data you have to convert it into consistent data by using these all methods. That is the visualization. You can do all these things before the data pre-processing. See what is the similarity data and what is the dissimilarity data. You have to separate it before the data pre-processing. These are the methods. These are the concepts you have to discuss today. What are the attributes you have to use, and what is the data visualization, and what are all things you have to discuss in data pre-processing. So this is the end of the basics of the basic history about the data warehousing and data mining. So here this is the theoretical concept. What you have learned up to in the first unit, you mainly have to discuss with that